and I'm the director of our Center for Social Science Scholarship, which coordinates our annual Social Sciences Forum Distinguished Lecture Series. This is our third Social Sciences Forum event of the semester, and I want to thank the Department of Economics for arranging this lecture on such an important topic. Before we begin, I want to take a brief moment to mention our fourth and final Social Sciences Forum lecture of the semester on November 13th. Nimi Waraboko from Boston University will give the 41st annual W.B. Du Bois lecture called The Future of Du Bois, Consciousness, Citizenship, and Epistemology in Africa. That talk will be at 6 p.m. on November 13th in the UC Ballroom. We hope to see you there. We've got some flyers back on the drinks table if you'd like to take one and join us. I'd also like to invite you to engage with us online and on social media. You can check out our website, socialscience.umbc.edu, and follow our MyUMBC group. We're also on Facebook and Twitter at UMBC Soc in case anyone out there is live tweeting, feel free to tag us. And thanks so much for being here. And I will now turn things over to introduce our speaker.
Hi, my name is Maria Bernero. I'm an assistant professor at the economics department, and I'm very pleased to present our presenter today. She's Professor Sheila Olmstead. Sheila is a professor at the Lyndon B. Johnson School of Public Affairs at the University of Texas at Austin, a visiting fellow at Resources for the Future, and a senior fellow at the Property and Environment Research Center. Sheila holds a PhD in public policy from Harvard University, and before joining UT, she was Associate Professor of Environmental Economics at the Yale School of Forestry and Environmental Studies, and a Senior Fellow at RFF. And recently, she served as the Senior Economist for Energy and Environment at the President's Council of Economic Advisors. Sheila is also an editor of the Journal of the Association of Environmental and Resource Economists, and she has also served as a Vice President and a member of the Board of Directors of this association. She was also Associate Editor of Water Resources Research, co-editor of Environmental Resource Economics, and book review editor of Water Economics and Policy. She has published in many prestigious journals, such as the Journal of Economic Perspective, Proceedings of the National Academy of Sciences, Journal of Urban Economics, Environmental Resource Economics, Land Economics, and several others. We're very excited to have her here today, and please welcome Professor Sheila Olmstead.
So thanks so much, Maria. Can you guys hear me? Okay, great. So I'm here today to talk about a little bit about the economic costs of water pollution. And I wanted to start by kind of showing you some pictures, first of all, of the kind of water pollution that I'm going to be talking about, and then asking you, why should an economist care about this? Like, why would this be an issue that someone who worries about microeconomics in particular, and right, these interactions between firms and consumers and how those things add up over an economy, why should I care about water pollution? So the picture in the upper left-hand corner, while you think about that, because you thought you were just going to come and sit and listen, but I'm going to ask you to tell me. In the upper left-hand corner, that's a picture of the Cuyahoga River in Cleveland, Ohio. It's on fire, as it looks like it is, which is kind of unusual for a river, right? That picture was taken in 1952. There was an even more famous fire on the Cuyahoga River that occurred in 1969, which is often talked about as one of many different impetuses for the Clean Water Act, which was passed in 1972. So the Cuyahoga River fire in 1969 was quite severe, but it was actually the 13th such fire since 1868. So about 13 times over a 100-year period, that river caught fire in the US. And obviously things are in better shape today. In fact, you can eat fish that are caught in that section of the river today due to a lot of things that I'll be talking about in a few minutes. But things have gotten a lot better since 1952 in the United States in terms of surface water quality, at least in most locations, kind of on average, okay? But there are a lot of parts of the world where, right, those kinds of surface water contamination conditions are, at least as bad as what we might have seen in Cleveland in 1952 in the United States, or even worse than that, and sort of depending on what pollutants you care about. So the picture on the upper right here is the Ganga, or the Ganges, as you might know it, the river in India. Picture from 2013. Down in the bottom left, that's industrial pollution in the Xiang River in China, picture taken in 2017. And then also another picture from 2013 at a coastal location in China, right, of water pollution at a beach in 2013. So why should I care? What do you think? Should we leave this up to aquatic scientists, Should economists be worried about this kind of a phenomenon? What might you worry about from an economic perspective? Go ahead.
My first thought would be that certainly there would be some sort of cost associated with humans not having access to these water sources.
Good, exactly. And for what kind of purposes? Like humans not having access to these water resources for what kind of purposes? Sanitation, hygiene, drinking water in some locations, right, might be a concern. What else? What are people doing down here at this beach? Swimming, wading, recreating, right? There's parents, kids and stuff, right, sort of swimming in that water where this algal bloom is kind of taking up a lot of space in the front. You might worry about things like if there's a lot of stuff in the water, kind of constituents from industrial processes and so on, and then that water moves downstream, and somebody withdraws it for drinking water purposes or even another industrial process, that they're going to have to spend a lot more money, right, to treat that water than they would have if the water was in more pristine condition when it came into their intake pipes. So there's lots of different uses that we have for water resources, and those uses can be, quite seriously impaired by the kinds of pollution problems that you see in these pictures. And in particular, you might also worry about health effects, right? And I'll be talking about health effects in a few minutes. So it turns out that the economics of water pollution control is sort of an area that's not nearly as well developed as what we know about air pollution in economics. And so I'm going to start by kind of telling you a story about what we know about air pollution and how that affects economies. And then we'll kind of walk through that and think about, is there some way that we can learn something from that about what water pollution might be doing, okay? So I'll start with air pollution, and I would show you a series of pictures that actually has some similarities to what we saw in the prior slide, right? So up in the top left-hand corner, you see a picture from the United States going back quite a ways, right? So this is a picture of Los Angeles in 1973, right? The LA area generally has a lot of problems, even meeting current standards for things like ozone or smog, right? And that's a picture, essentially what you're seeing there is a picture from 1973, so quite a long time ago. Right, it's a picture of LA in 1973. But then, right, if we look at modern developing country cities, places like Beijing, up in the upper right-hand side, this is a picture from 2017, right, a view of Beijing during a particularly severe air pollution experience. And then New Delhi in India, right, there's a picture from 2018, just a year ago. And then just a few years ago, Mexico City down there in the bottom right. And so the point is, right, we've done a lot, again, just like we did on the water side, a lot of things to clean up air pollution in the United States since 1973. We see that in a sort of change in views and lots of other things, as I'll talk about in a minute. But there are still places around the world where this is a relatively severe phenomenon and has some significant economic costs associated with it.
Is your microphone on?
It says that it's on. Yeah, it's on. It's just not high enough. I can stand over here. Is that better? Yeah? Okay. Okay. So what do we know from economics about those kinds of air pollution experiences that we saw in the pictures in the prior slide? Well, we know a few things. We know some things from studies of the damages that are created by air pollution events, and we know other things from studies of regulations and other approaches that reduce air pollution, right? So sometimes when we talk about damages, sometimes I'll talk about benefits, right? It just depends on the context of the study. But we know from these kinds of studies that reducing air pollution does things like reducing infant mortality. We know that it reduces adult premature mortality and respiratory and cardiovascular illnesses. We know it reduces the incidence of premature births and low birth weight. And we know that it reduces student school absences and has some other important educational impacts as well. We also know that reducing air pollution increases student test scores. It increases short-run worker productivity, so especially in things like outdoor occupations such as agriculture or construction. But there's increasing evidence that it increases worker productivity in other professions, indoor professions as well, everything from sports referees or umpires to survey enumerators and other kinds of indoor work that's been studied in this context as well. And then really importantly, more recent research has focused on the long-run effects of impact of exposure to pollution, and especially exposure to pollution in very young childhood or even in utero. And what we know from some of those studies is that long-run earnings, long-run labor force participation, these kinds of important kind of labor market outcomes among adults are influenced directly by their exposure to pollution in early childhood. And these impacts on human health and human capital formation are very large in many cases, and they're very convincingly demonstrated in the literature. There's a review article that I'm pointing you to down here from 2013 in the Journal of Economic Literature that goes over kind of some general conclusions from that literature and is really useful if you're interested in those studies. But I'll just give you kind of a few examples from the recent literature. And as I mentioned, a lot of this work now is being done in developing countries, right, where we still have some very severe air pollution events that are occurring, especially in major cities. One example of that is some studies on particulate matter that have been done by my colleague Avi Ebenstein and his co-authors. And their work suggests that Chinese particulate matter concentrations reduce average life expectancy quite significantly. And that even if China were simply to bring all air emission sources into compliance with its own existing, what are called Class 1 standards for particulate matter, would save 3.7 billion life years, right? So if you're talking about a country in which pollution is quite severe, sometimes even small changes, right, spread across a very large population can have really impressive impacts on human well-being. Another example is a study by my colleagues Michael Greenstone and Rima Hanna from 2014, in which they look at India's requirements that cars install catalytic converters, which started in 1995. A catalytic converter is a really common means of reducing sort of emissions from automobiles. And when they introduced this regulation in 1995, my colleagues estimate that, again, sort of really significant impacts on infant mortality, reducing infant mortality in India. In the US, there are studies going back well before 2003, but a really good one if you're interested in this work by Greenstone and Ken Shea. Again, focuses on particulate matter and looks at what happened in the United States with reductions in the 1980s. And they show that, gosh, if we hadn't seen some of those reductions between 1980 and 1982, then an additional 2,500 infants may have actually died as a result of the air pollution levels had they stayed kind of at business as usual rather than coming down the way that they did. And then again, importantly, focusing on these long-run impacts, there's a study in 2017 showing that higher pollution levels in the year of your birth actually is associated with lower labor force participation, so fewer hours worked, maybe increased likelihood of unemployment and so on, and lower earnings at age 30, right? So even once you're through with college, right, you still can be affected, at least in a very large statistical sense, by that early childhood exposure. So we know these things, these very important things that have economic meaning to them about air pollution exposure. Why would we estimate these things? Again, right, I'm sort of asking you the same question, but in a more general sense, right? Not only why should I care about water pollution, but why should economists care, right, about monetizing pollution benefits altogether, right? Whether it's air, water, or something else. And there are a lot of answers to this, but one that I think is particularly compelling is that if you think about the context of regulation, right, this like practice of imposing on firms, households, and other entities, right, changes in their practices so as to reduce risks to environmental health and safety, then you're in a context in which benefit cost analysis is often highly relevant. So in the United States, for example, going all the way back to President Nixon, right, through executive orders and congressional measures, agencies have to perform a rigorous benefit cost analysis of any regulation that is expected to have a cost to the US economy that exceeds $100 million. And you'd be surprised how quickly you can get to a cost of $100 million. It was never indexed to inflation, so that's actually the same number that it was back even in the early days. But it's pretty easy to get to that level of cost when you're talking about something like corporate average fuel economy standards or energy efficiency standards for refrigerators, right? Or something that's going to affect a very large number of transactions, right, between firms and consumers around the country. So this process is called regulatory impact analysis. And when policymakers do this analysis, right, they have to have an estimate of the benefits and they have to have an estimate of the costs. And as you know, costs are hard to sum up sometimes. There are some challenges to estimating the costs of future regulations, but generally it's a lot easier to do that, to kind of tally up the numbers on the cost side than it is on the benefit side. And that's partly, at least in the case of pollution control, because a lot of those benefits, things like avoided premature adult mortality, avoided infant mortality, impacts on recreation or views, or right, lots of other things, are non-market effects. Right? They're not things where you can sort of go out, in an existing market for air quality, right, look at the changes in prices and quantities that happen as a result of the regulation and start sort of adding up, right, those sort of squares and rectangles or squares and triangles in a simple welfare analysis to get your benefit numbers. Instead, you have to find some other creative way of understanding how to put dollar values, right, on some of those kinds of impacts in order to get that number on the benefit side. And so developing these credible estimates of economic benefits is just an essential input, right, into this this regulatory process in the U.S. And even when it's not, right, so if you take, you know, small rules and regulations that maybe don't make it over that $100 million per year threshold for costs, and or contexts in other countries where benefit cost analysis is not required for policy making, right? That might be the case for the catalytic converter rule in India, right, or Chinese, particulate matter standards and so on. You can still, through the generation of these estimates, provide really important information for policymakers to make decisions about, you know, hey, if we're trying to improve lives, right, should we have less traffic congestion or less air pollution or some of both, right? Should we put our money and our resources into, right, this or that? And understanding where in that spectrum pollution falls is, I think, a very important thing for folks facing limited budgets, which is certainly true in developing country settings. Okay, so what kinds of impacts would we monetize? Well, the first types of impacts that we tend to monetize are those human health effects, right? So if you think about those papers I was citing that say, you know, we'd avoid infant mortality, avoided adult premature mortality, it shouldn't be surprising that those kinds of impacts from pollution tend to be the lion's share of estimated benefits from things like air pollution control regulations, like a clean power plan or a corporate average fuel economy standards, those kinds of things. Okay. And so how do we do that? Well, most of the time, the studies that do this are studies that exploit differences in wages across occupations that also have differences in risk, right? So looking to see how workers might be willing to trade off some additional compensation for some additional risk that they face in terms of environmental health and safety, right? So that's a really common way of doing that. And if you're a regulator, somebody like at the EPA, generally you're going to take a whole bunch of such studies from literature, and essentially what they're doing is taking an average, right, of the estimates they get from those studies, and they come up with these measures that help them basically monetize the value of those changes in risk represented by the air pollution regulations or water pollution regulations. Another set of impacts would be things like impacts on markets like agriculture, forestry, commercial fishing, right? So if we're talking about water pollution in particular, right, you can imagine that, you know, blue crab harvests in Chesapeake Bay might go down, or, right, salmon harvests in Puget Sound or something like that might go down. And so those are somewhat easier, right? Those are market effects. Those are going to leave a direct footprint on prices and quantities in the markets for those goods and services, and so then you can, right, sort of use that information to understand the welfare impact. Other non-market activities that are not health related would be activities like recreation, and we have methods for doing that too. We can use information on visitation at recreation sites and see how that changes with something like air quality or water quality, and we can exploit the amount of money or time that people are spending, right, to get to those places, and through that, right, sort of statistical method using that variation, we can estimate the value of those kinds of environmental quality changes on recreation. And then finally, another important area that where we monetize these impacts is through housing markets, right? So if air quality improves dramatically and the views from downtown Los Angeles improve dramatically, then the property values in those places tend to increase as well. Those kinds of property market impacts would include some of these things we've talked about here, right? So if home buyers and sellers know something about the health damages from air pollution, then that might explain some of their willingness to pay more for houses in places with cleaner air. Or if that improves hiking and views and, right, other things, right, then those kinds of things would also be wrapped up in property market effects as well. And I'm going to talk a little more specifically about how we do this when we estimate these impacts through property values, because it's going to kind of be an important factor for one of the pieces of research that I'm going to talk about in a few minutes. So the example is something called a hedonic property model. Okay, this is the type of method that economists might use to value pollution through property markets. And the basic idea is that when you buy a house or an apartment, right, or some kind of location, the house price comprises several different components that add up to its total value. Okay, and that would be different additions to price that are associated with the physical structure, right? How many bedrooms, how many bathrooms, how big is it, so on and so forth. Neighborhood characteristics, like what's the quality of the school district, what's the crime rate like, how close is it to work centers or transportation corridors, and so on. And then importantly, for our purposes, it also includes some components of the environment. Is it close to parks? Is the air quality good? Is the water quality good? And so on. And so the price of the house is really the sort of sum of implicit prices for all of these different home characteristics. And so what you're going to do is you use this model, right, to kind of disaggregate those property characteristics and try and isolate just that part that is that part of the price, right, that is from the air quality or the water quality concern that you're interested in valuing and monetizing. And I'll give you this sort of heuristic application. See if I can walk over here, and maybe I'll just shout so that you can hear me. So the idea is, imagine that we're in Los Angeles, and we're interested in knowing, Los Angeles is a place that often has problems with smog or ozone. And you want to know, how does that affect property values in Los Angeles? Well, you could take a couple of different communities. There are many, many different places you could choose to live in the Los Angeles area, right? One is Santa Monica, which is right on the Pacific Ocean, right on the coast. And another is Pasadena, which is kind of closer up to the foothills of the San Gabriel Mountains, okay? Right, so further west. And there are a lot of differences between these communities. Okay, one big difference, and important for our analysis, would be that the median home value, this is in 2001, in Santa Monica was about $626,000, and the median home value in Pasadena at that time was about $286,000. So that's a big difference, right? What explains the fact that you have to pay $700,000 right at the median for a house in Santa Monica, and just under $300,000 for a house in Pasadena? There are a lot of things that could explain that difference. Maybe people like living close to the ocean more than they like living close to the mountains, right? So views, right, recreational opportunities, right? Maybe that sort of affords a higher price, right? So the realtors all say location, 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 right? So maybe that has something to do with it. Maybe it has something to do with, right, Santa Monica being kind of more central, more sort of closely located to LA. It's an easier commute, so you're closer to, right, sort of work opportunities and so on and so forth than you are if you're in Pasadena and you work in Los Angeles. Maybe it has something to do with differences in household income, what people can afford in these communities, right? So in the same year, 2001, median household income in Santa Monica was around $51,000, and in Pasadena it's just a little lower, around $46,000. But maybe it also has to do with the fact that the two have very, very different air pollution conditions, right? So in 2001, Santa Monica spent 1 day above the state's ozone standard. That's that smog, right, that you saw in the view of Los Angeles from 1973. And the wind direction moving from west to east on a typical day in coastal California, Southern California, pushes a lot of that kind of, right, the sort of constituents of and the pollution itself in the direction of these households in Pasadena, and then sort of traps it up against those mountains. And so not surprisingly, in Pasadena, residents would have experienced almost a month of days, right? So a lot more time above that state ozone standard in 2001. So to the degree that that was either, people didn't like that their views were obstructed, or they understood the health effects of that pollution, or for any other reason, right, some of that difference in house prices might be explained from those differences in, in exposure to air pollution. So that's the basic idea of that kind of a model, and we're going to come back to that in a water pollution context that I'll talk about toward the end of my talk. Okay. So now back to water pollution, right? In the United States, we had conditions like this in 1952, but those conditions continue to prevail, right, in places around the world that are important to many of us. And we know a lot less about the economic impacts of those kinds of water pollution problems than we know about air pollution, right? So I just went through all kinds of studies, recent studies, older studies, right, that really have this nice kind of established literature on what the economic impacts of air pollution look like, and we just know a whole lot less about water pollution, which is what makes it interesting to me. One thing we do know about is access to drinking water, right? So not kind of what's the water quality in the river outside your house, right? But what is the water quality coming out of the tap, right? Or the groundwater well, or the spring that you're getting your water from, right? We know a lot about that, and that is actually quite well studied. And just like for air pollution, we know that having clean drinking water has a profound impact on human health, right? Both at the individual scale and also at the population scale. So just for an example, we know some of this from retrospective studies of things that happened a long time ago in industrialized countries. So really nice paper by David Cutler and Grant Miller in 2005, showing that just this large-scale adoption of drinking water chlorination and filtration, right, two of the kind of main functions of your local drinking water treatment plant, that was introduced for the first time in 13 major American cities between 1900 and 1936, had a dramatic impact on human health. Dramatic reductions in premature mortality, and especially for infants and kids. Their estimates of the social rate of return to those water infrastructure investments in chlorination and filtration systems exceed 23 to 1, which is just tremendous for public investments, right? You just don't see those kinds of returns for most public projects in the current day. And that doesn't even count. That just counts the impacts on mortality. It doesn't count the fact that people would be sick less often, that they might have been more productive in their jobs, and so on and so forth, right? So it's just a partial picture, and yet the returns, the net returns, are really very high. We also know that from studies of more recent interventions in developing countries, right, that are sort of on a different part of their kind of path in that way. There's studies of Brazil, Argentina, many, many other places that again suggest that when we intervene, we make these large-scale investments in public health through drinking water supply, we have some pretty dramatic impacts on reducing premature mortality and improving health. So we know a lot about that. Well, at least not as much as we know about air pollution, but we know a lot more about that than we know about this problem, right? The problem that I showed you some pictures of, which is what about just water quality out there in the environment, which we'll call ambient water pollution, not the water coming out of the pipe in your house, right? But the water that's in the river, the stream, the lake, the ocean, right? Wherever it is that you're experiencing exposure to these kinds of water resources. And if you take the case of the United States, we've had some fairly dramatic improvements in water quality over the past many decades. Right? Remember the Cuyahoga River fire? The last one was in 1969. 1972, we have the Clean Water Act. There's a really nice paper published just this year in the Quarterly Journal of Economics by my colleagues Dave Kaiser and Joe Shapiro that shows actually some of the incredible decline we've seen in water pollution in the United States since then can be causally attributed to the Clean Water Act. Maybe not as much as we might have thought, but certainly some of it. And some of that decline is pictured here. Okay, so this is the change over time from 1972 to 2014 in the share of US waters that are considered not fishable. And this is actually a really common index that's kind of constructed and used often by organizations like the EPA. It comprises a bunch of different types of measurements, so dissolved oxygen, biochemical oxygen demand, bacterial concentrations, and so on. And this index, right, is sort of constructed so that we can say, you know, at what point would we say it is not safe to catch and eat fish from that river, right? Or we might put limits on the number of fish or the amount, right, some weight of fish that one should consume, right, on an annual basis or something like that from that river. And that share was actually quite high back in 1972, so we're kind of between a quarter and a third of, right, sort of water bodies in the United States would have had that not fishable designation in 1972. But that's come down quite a bit, and in 2014, right, we're around, say, 15%, right, just above 15%. So we've had a pretty significant improvement, maybe almost a halving, right, of the number of places where we'd say, hey, yeah, don't fish and eat the fish from that river. So that's kind of impressive. But the challenge is that we've done that through sets of regulations. And another paper by Kaiser and Shapiro, this is a forthcoming paper in the Journal of Economic Perspectives, written super accessible, easy to read. So if you're interested, I would urge you to take a look. Looks at the benefit to cost ratios. That is literally just, right, the numerator, it's a single fraction. The numerator is the monetized benefits, the dollars of benefits from a regulation, and the denominator is the dollars of estimated costs. So it's the benefit to cost ratio of regulations that target air pollution. Those are the blue columns. And those that target surface water pollution, right, those are the kind of clear dotted columns, among regulations passed in the United States. And what you see is this line here, this red line here, is drawn at 1, right? That would be the value at which the benefits of the regulation are exactly equal to the cost, right? The numerator is exactly equal to the denominator. And so what you're looking for, if you're using this as a measure of regulatory efficiency, right, whether we think that there are welfare gains or not from this policy, then you're kind of worried about wanting things that are on the right side of that red line at 1, right? Indicating that the benefits in the numerator exceed the costs in the denominator. And if you're below 1, then the opposite is true, right? Then the denominator is bigger than the numerator, or costs are greater than benefits. And what you see here is that the sort of story I was telling you about air pollution, which is one in which the large majority of regulations that have passed have estimated benefits that are well in excess of their costs, right? The benefit to cost ratio is quite a bit larger than 1. All of this density here in this bar, right, are regulations for which the benefit to cost ratio exceeds 10, right? So for every dollar you're spending on costs, you're getting 10 times that amount in benefits. And that's really quite impressive. But what we see if we look at the surface water regulations is that the density is concentrated kind of around 1, but you know, there's actually a lot more regulations that where we have sort of estimated costs exceed estimated benefits than those that fall on the right side of that line at 1. right? And that would suggest, you could raise questions about the efficiency of those investments and those water quality improvements. We know surface water pollution has declined, but when we look at the evidence that's been generated by regulatory agencies, these estimated benefits and costs, it sort of doesn't look like it's been a great investment, right? That's what one takeaway that you could sort of take away from this graph. And so I want to raise some questions about what could be driving that and whether that's a real thing, right? And in which case we should say, well, maybe those regulations just shouldn't be so stringent in a place like the United States, right? Maybe we've cleaned things up to such a degree that on the margin, doing more is probably not a good idea. And that's not to say that it wouldn't be a good idea in China or in India, right? Places that still have much more severe water pollution problems on average than we do. But it would be a reasonable conclusion to draw about the United States if you looked at that graph and you had no other information. But there are other possibilities as well, and that's what I want to go through, okay? And then talk about some research that's trying to shed a little bit more light on this. So possibility one is just, that the benefits of water pollution control out there in the environment, not coming out of your tap, right, but just out there in rivers and streams and bays and estuaries and oceans, are just smaller than what we would estimate, right, for an air pollution control improvement, because we would tend not to see human health impacts from those water quality changes. Well, why would that be? Well, if we're talking about air pollution, I'm sort of out there, I'm working, I'm playing, I'm out there in the environment, I leave my house even just to go, kind of go to my car every day, right? Maybe some of us get a lot more exposure than that, kids are walking to school and so on, and we're just exposed to air pollution in a very intense way. We are literally breathing in, right, the sort of kind of smog that we saw in those pictures when we're living in places where that stuff happens. And we can mitigate that, we can buy masks, right? Sort of respirators. We can put filters, air filters in our homes. Our air conditioners essentially kind of do that, right? So indoor air quality sometimes is higher than outdoor air quality. And we actually see that in some places. Have you guys seen pictures of people wearing masks with high levels of pollution, or even just traveled, right, or come from a place where this happens on a regular basis? So people do this. But it turns out it's kind of hard and sometimes costly to avoid, right, actually incurring those health damages from air pollution. But when we think about pollution in rivers, lakes, right, oceans, and so on, we saw some people swimming, right, at a polluted beach in China. But most of those other pictures, and there were some people wading in the picture in India, but there was nobody in the water in the Cuyahoga River when that was on fire. There was nobody in the water in that picture of industrial pollution at a dam in China. And so it turns out, right, that it's just easier to avoid exposure to those kinds, or at least intense exposure to those kinds of pollutants if it's in the water versus in the air. And so one reasonable conclusion would be, maybe that's why the benefit estimates for air pollution are so high and the benefit estimates, right, for water pollution are relatively lower. So that's one possibility, and we will explore that in just a minute. Another possibility, so that's a possibility that has to do with the numerator just kind of being small by nature, right, of the benefit to cost ratio that we saw in that graph. Another possibility is that the denominator is bigger than it otherwise would be, because we've used very costly measures to try and achieve those gains that we saw, right, that sort of big steep decline in water pollution that we see in the United States. Maybe we've just done things that are very costly, and we'll explore that possibility in just a minute as well. Another possibility is that the benefit estimates might be missing some important factors. Maybe we've, right, sort of gone after some things, but there's some things that we've missed, okay? And that would suggest that we got to do something about that, right? If we don't want to sort of leave those numbers on the table and leave that unanswered if we think we're just missing some important factors. And then finally, I want to talk about the possibility that there are opportunities to improve the methods that we've used to estimate benefits. Not that we've gone after the wrong stuff necessarily, but maybe we haven't done as good a job as we could with econometrics and our, right, sort of statistical tools to try and estimate those benefits and then put dollar values on them. And notice again, right, that these first two possibilities, right, if it's really true that the benefits are just small, well, then they're just small, right? And again, we could sort of conclude from that benefit to cost ratio graph that maybe we ought to put a little more money into air pollution control, a little bit less into water pollution control, right, or make some other such trade-off, and we could actually improve welfare. And if it's possibility number two, well, that would suggest, why don't we use some different approaches, right? Some cheaper approaches to reduce water pollution. Maybe we can decrease that denominator a little bit, and that might help us out as well. But these two have to do with maybe economists not doing our job as well as we could or should, okay? And those two I'm going to spend a little bit more time on than the other two. All right. Possibility number one, we've already sort of touched on this, right? We certainly know from developing countries, right, in addition to those drinking water studies, we also have some recent studies that suggest that just reducing water pollution in rivers and streams actually improves people's health. And that's largely because some of the pollution concentrations we see in those settings are extraordinarily high, right? So it's not crazy to think that in some cases, right, in the kinds of pictures that I showed you earlier, right, even right, maybe back in the day in the United States when the Cuyahoga River was catching fire, maybe we would have had some health improvements, right, from making that situation better. So again, Avi Ebenstein does some work in China on this, looking at, hey, what if China doubled the tax that it currently imposes on wastewater dumping in rivers? He estimates that they could avert 17,000 premature deaths per year from digestive cancers at a cost of about $500 million. That's less than $30,000 per averted premature death, which I can tell you from studying environmental health and safety regulations, like that's a bargain. I know it sounds like a lot of money, but not for sort of an averted premature death. Brainerd and Menon in 2014, again looking at what happens if, right, your mom is pregnant and during the sort of agricultural production season, and so she and thus you are exposed to elevated levels of things like fertilizers and pesticides in local river waters. They show this actually increases infant mortality, and they show that it reduces height for age and weight for age among kids 0 to 5. Again, so some important health impacts that have to do, again, sort of that future labor productivity, wages, all of those other things that economists care about as well. And then finally, again, another example from India showing, right, that if we see exceedance of existing surface water standards in India, this time not from agricultural chemicals, but from tannery effluent in the Ganges River, again, raises neonatal mortality by 10 to 14 percentage points, which again is a big effect. So we know sometimes ambient water pollution has important health impacts. We don't know much about the United States, right? There have been these retrospective studies of drinking water interventions. I don't know of a retrospective study on the health side, right, of what happened when we sort of no longer had river fires. Did that have the same kinds of impacts that we see today, right, if we have interventions in places like China and India? We just haven't studied that. I think it's a really sort of interesting potential area for research. But I also think that you'd have to admit that in the current day United States, right, in other industrialized country settings, given the much higher average surface water quality than places that are being studied like the 3 papers I just named, any such health effects are likely to be fairly small, maybe even 0, right? Given, right, those sort of the different, very, very different average starting conditions. Could it still be worth examining? Maybe. You know, these health effects have big numbers associated with them and those air pollution control regulations. So if there are health effects from surface water pollution, we'd probably want to know that. Even if they're small, again, projected over a large population, right, that can mean some significant monetized benefits from reducing that pollution. And also, a lot of this evidence that I showed you on the developing countryside comes from evidence about the impacts of agricultural chemicals in particular, fertilizers, pesticides, and so on. And that stuff, as I'll talk about in just a minute, is not really regulated under the Clean Water Act in the United States. We don't do much to sort of control the flow of those kinds of chemicals into water resources. So if that's causing health effects in developing country settings, it could also conceivably be causing health effects here in the US. There's some early evidence in the epidemiological literature that that could be a concern. And so again, it's an area that economists could maybe shed some light on and could look at, but it may or may not turn out to be a big and important factor. That possibility number 2, maybe the regulations are just costly, right, relative to the kinds of things we put in place to control air pollution. I think that's also possible. Most water pollution rules are promulgated in the United States under the Clean Water Act of 1972, and the stated goals of the Clean Water Act were, 1, the attainment of those fishable and, in fact, swimmable, which is a much higher standard, waters by 1983. Everything was supposed to be fishable and swimmable by 1983. And we were supposed to eliminate all pollution discharges to navigable waters by 1985, just 2 years later. Have we attained those goals? Anyone? No. Okay. So that was incredibly ambitious, right? And for an economist who knows something about, gosh, as you remove more and more pollution, right, trying to approach a 0 discharge, right, we would expect those costs to ramp up really, really steeply. So if, in fact, even though we haven't achieved those goals, if we've tried to approach those goals through the regulation, we could very well have implemented some very, very costly regulations relative to their benefits. So that certainly is a possibility. Another thing that's relevant here is that those agricultural chemicals, things like fertilizers, pesticides, right, agricultural pollution is probably the low-hanging fruit here in a lot of parts of the United States. It's the primary cause of kind of remaining water quality impairment in the United States. And it's almost completely exempt from Clean Water Act rules. So we've got really sort of fairly expensive and getting more expensive, you know, controls on things like industrial facilities, municipal wastewater treatment plants, and so on, really no controls or very few controls on agriculture. And when you have one sector that's really not regulated and that's where the cheap stuff is, right, and you've got the expensive stuff going on here, that would suggest maybe we could do some rebalancing and make things a little cheaper. So possibly, right, this argument about kind of costly, excessively costly regulations, that's possible, and I think that's something worth exploring. The third possibility is this idea that benefit estimates are incomplete, right? So what would a complete estimate include? Well, many of the things we've already been talking about. Health effects, if there are any. Recreational effects, right, on fishing, boating, swimming, surfing, wildlife watching, anything, right, that people are doing in and around water that's affected by water quality would be important to include. Climate change impacts, that might seem like a weird one, but I'll talk about it in just a minute. It's the subject of a recent paper of mine. Those property market impacts that we talked about before, and then those commercial impacts on fisheries, agriculture, forestry, and other sectors that are affected by water pollution. And then again, those increases in treatment costs for downstream water users. So that would be sort of a fairly complete set of benefit estimates for surface water pollution controls. So I think we've done a pretty good job with some of those. As I said, we don't have a handle on health effects, but those might be small in the US setting on average. We've done a lot of estimates for recreation and hedonic property models and so on, and I'll talk more specifically about those in a minute. But just to give you a sense, like, is there anything that could be missing? I think yes is the answer to that question. So one example would be climate change benefits of reducing water pollution. So there's some current papers by my colleague John Downing. Those are the first two that are cited up here, and his co-authors, showing that when lakes have too much kind of nutrient pollution, too much nitrogen, phosphorus, and so on running off into surface water, that causes this problem called eutrophication, which is a process in which those nutrients, which are really good for plant growth, cause lots of overgrowth of algae, and when those plants die and sink to the bottom and decompose, they use up oxygen. When they use up oxygen, the other stuff in the water, plants, animals, things like fish, crabs, and so on, right, those critters have a hard time, and they either have to leave that hypoxic zone, right, the zone that's depleted of dissolved oxygen, or if they can't do that, they're not going to live, right, they're not going to survive. And so the extreme version of that would be something like a dead zone, right, which happens annually here in the Chesapeake Bay, it happens in the Gulf of Mexico, Long Island Sound, coastal North Carolina, Puget Sound, right? Almost all kind of urban coastal areas in the United States have experienced this phenomenon. And my colleague, who's a limnologist, right, so a scientist who studies lakes, has shown in some recent work that when that happens, that process of eutrophication happens, that emits methane, which is a potent greenhouse gas, right? It's much more potent in the short run as a sort of higher global warming potential than carbon dioxide. And they estimate that methane from eutrophic lakes worldwide has a climate change impact equivalent to a fifth of global fossil fuel combustion. So it's actually quite a significant contributor to climate change, and then, right, they estimate going forward, they expect that to increase. And so with John and with other colleagues and co-authors, we use some estimates of the social cost of methane, some really nice estimates developed by a team of researchers across the US federal government under the Obama administration, to estimate that the present value of the global climate change cost of that eutrophication process between 2015 and 2050 could be in the sort of multiple to tens of trillions of dollars, depending on what discount rate you choose, depending on, right, how bad you think that problem is going to be by the time we get to 2050, right, but very, very significant economic impacts. And my colleagues and I know of no case in which these potential climate change impacts of this very significant water pollution problem have ever been included in a benefit cost analysis of regulations. So we know some things are missing, and they could be important in some contexts. And then finally, there's this possibility that we just haven't done a very good job. Maybe we've looked at some of the right things, like health or recreation or amenity values of some kind, but maybe we just haven't done a very good job. Right? Maybe we could do better at estimating those values. And I think this is a real possibility as well, and I'm working on a project, a couple of projects that's trying to do this, trying to do a little bit of better job coming up with estimates of the monetary value of improvements in water quality. So what's the problem? So we have these recreation demand studies I mentioned earlier, right, exploiting, right, differences in visitation behavior and what people are willing to spend in terms of time and money to go and recreate at places that have water. And there's a small number of those. There's a huge literature on that altogether, right, on recreation demand, but a really, really small portion, only 12 papers that I know of, that ask the question, how does water quality, right? If water quality improves, does recreation increase? Do people spend more time? Do more people recreate at these places, right? There's some really important ones, right, to which even folks here at UMBC have contributed, but there's a small number of them. There's 12, okay? So, and in addition, some of those are pretty old, and even the more recent ones don't use what we would call sort of modern econometric tools that would give us some confidence that those estimates are plausibly causal, that we really think we've estimated a causal relationship between recreational value, right, the sort of this monetized value of recreation, and water quality. There are lots of property value studies too, right? I mentioned these hedonic property studies. There are 20 of those that I could find in the literature, right, that estimate the value of water quality improvements and look to see whether housing markets have capitalized that value and then assign some dollar values to that. None of them are what we would call plausibly causal. So none of them have used these methods where we think, you know, we're pretty solidly sure that these are causal estimates. And so my feeling about this is that, gosh, we really want to throw our best stuff at this before we conclude, right, that the benefits of this stuff, the water quality improvements, are just low. And we haven't done that. And if we were to do it, we might get very different answers than we've gotten by using the older methods. And it's really important, right? The estimates could be really quite different. So I'm going to give you an example of this from my own research, what I'll call the methods problem. And what I would say is, when I think about the ways that we try to value pollution as economists, I think hedonic property models are among the most appealing, because they get at some of these really big non-market values, things like impacts on health and recreation and amenity values, right? Things just look better, smell better, right? You're sort of happier to be outside around your house and so on. And they do that by looking at market transactions, right? One way to value those things would be to ask people. We could do surveys, and we do, right? There are economists that do really highly structured, rigorous surveys, things that we would call contingent valuation or other sort of stated preference methods, where we ask people to tell us how they value those changes. And it turns out we're just much more confident when we see people actually spending money, right, putting some skin in the game and telling us something about, through their market transactions, telling us something about their valuation. And the housing market approaches allow us to do that. And it's nice because they allow us to do that even for things that don't really have a market, right? So there's no market for air quality. There's no market for water quality. Well, depending, if you're in California, right, there's a market for air quality, or for some part of air quality. But if there's no market for these things, still they leave a footprint in some market. And in this case, that's the housing market, right? We're looking at property prices to try and to learn about this. So my challenge is that when I look at what we've done, and these have been used for a lot of non-market things, school district quality, crime rates, right, all these other things that we said go into housing values, somebody, right, you pick your topic and somebody has done a hedonic property study to understand, right, valuation through the property prices. But when we apply these things to water pollution, what I'm arguing in some of my current work is we haven't done a very good job thinking about how people are really exposed to that in their daily life. So for air pollution, I told you a story in which I said, you know, I walk outside my house, even if I'm just going to the car, even if my kid is walking to the bus stop or walking to school, right, or I'm walking to my job, or, and I'm exposed. Unless I'm wearing a mask, unless I invest in some kind of mitigation, right, or avoidance behavior, I'm just exposed to that air pollution. And so what people have done in these hedonic property studies for air pollution is they've taken sort of observations of property transactions, and then they've taken, like, each house, they kind of put it at the center of a circle that has a varying radius, and they'd say, okay, how do I measure the air pollution that's close to that house? Well, I'll draw a circle of a radius of 1 kilometer, 2 kilometers, 5 kilometers, right? And then I'm going to take all the air quality observations within that circle, and I'm going to average them in some way, and I'm going to call that, right, the kind of, you know, air quality at that house. And then it's fairly straightforward, right? I get a bunch of property prices, I've got a bunch of observations on air quality, I'm controlling for other stuff, and I estimate that effect, right? That marginal part of the price, the housing price, that is, you know, explainable through air quality. The challenge is that people have done this for water pollution as well, right? That's the nature of some of those 20 studies that I mentioned earlier. In fact, most of them. I take a house, I draw a circle, I take all the water quality monitors close to that house, and I average them and I say that's that household's exposure to water quality. But that seems to be not maybe the right way to me. I'm going to call that the exposure by proximity method, right? That I'm just going to sort of take, right, the water bodies that are close to me, and I'm going to call that kind of my water quality. And not surprisingly, when we do that, when we draw those circles in the water context, the estimates of that valuation, right, that addition to the price from good water quality, go to 0 around 2 or 3 kilometers, right? So 1 or 2 miles away, then I just don't care, right, about water quality. That's what those estimates imply. Okay, so that seems a little odd to me. Anybody have like some intuition why that might not be so great? Yeah, go ahead.
I mean, at least when you were talking about, like, effects for recreation, a lot of people, if they, like, you know, go boating or swimming in a lake, it's not within a mile of their house.
Yeah, And so if it's going to 0 within 1 to 2 miles, you'd sort of go, well, maybe it's not capturing that part. Maybe it's capturing, the fact that if I walk out, I take my dog for a walk and we're at the local creek, I'm less concerned about her drinking from that creek, right? But that's probably not our biggest concern about water pollution, right? So I am an aquatic recreator. I swim outside probably 2-3 days a week. It's one of the greatest things to me about living in Austin. There's lots of places where you can do that in actual fresh water, right? I can do it in the pool, but I can also go out and swim someplace, right, in nature. And I'm going to use that to explain why I think this exposure by proximity method is probably not going to work, and it's going to come down to exactly what you said, right? That I don't think that's a good way of estimating people's value for, right, their exposure to water pollution in that setting. Okay, so this is a map of Austin. It's only a part of Austin, but it's the part that includes my house. Okay, so my house is right here. This is Sheila's house, okay? And if I said to you, like I just did, that I'm an aquatic recreator, I love to get out and swim outside, and I showed you this map of Austin, I've kind of given you a hint by putting my house way up here in the kind of northeast corner of the map. But if you were to guess, where does Sheila swim outside, what would your guesses be? Any thoughts? Where might you put me? Where would you swim on this map? The big chunk of water, right? Okay, so maybe, right, if I'm starting to average, I'm drawing circles around Sheila's house, like the first thing I'm going to catch is probably over here. This is the Lower Colorado River that runs right through the center of Austin. This is Shoal Creek, this little water body right here. That's where I'm walking with my dog, right? So that's my, and so maybe, my small circle is going to get Shoal Creek, where my dog drinks from the water. I wish she wouldn't, but what are you going to do, right? This is what they do. The big circle maybe captures over here, but here are my swimming spots. Right, so this is Sculpture Falls down here on the left. Okay, so this is a really great place to go swimming. These are 2 of my kids, and so they get in there, like they get under the water. It's in their ears. Like I really care about the water quality there. Right. This is Barton Springs. It's 1/8 of a mile long. It's 68 to 70 degrees year-round, which feels really good when it's like 105, as it often is in Austin. And I care a whole lot about the water quality here. But if you drew a circle around my house that was big enough to catch Sculpture Falls and Barton Springs, you're going to catch a whole lot of water quality monitors that I don't care about. I've never been here. It's like you've got this creek over here. I'd never visit that. That's Waller Creek, right? All these probably lots of monitors in here. There's some drinking water sources in here. I care, but right, the stuff that I really, really value is the places that I go, right, to recreate. And so you're going to draw a big circle, and what happens is the circle gets bigger and bigger as I've got a whole bunch of monitors in there, and maybe I get a big enough circle to get these 2 in there. But by the time I've done that, I've got so many monitors that I don't care about that I'm probably going to get an estimate of 0, right, of how much I value that, how much that's captured in my property price. And I like to equate it to restaurants, right? So if somebody said, like, what's the restaurant scene in Austin worth to you, Sheila? Well, it's kind of worth a lot. I like the fact that I can go out and have really good food. This is Franklin Barbecue. Does anybody know what Franklin Barbecue is? What is Franklin Barbecue? Come on, someone who nodded. Yeah, Tim?
Well, I've heard of it. I've seen stories about it.
Yeah. Yeah, people line up at like 6 in the morning. It opens at 11, and then they're out of food by 2. And if you don't get the food, sorry, come back next time. So it's really, really good. But again, right, how would you know, unless you knew something about my visitation behavior, how would you know that I value that? And if you drew a circle around my house big enough to encompass that, I'm going to get the KFCs and the Burger Kings and the McDonald's, all this stuff that I don't really care that much about. And even if it's close to my house, that doesn't tell me anything, right, about how I value it. So that's my concern about the approach that's in the literature. And what my colleagues and I do in our current paper is we study this nutrient pollution problem, this hypoxia problem or eutrophication that I was talking about earlier in Tampa Bay. So Tampa Bay, Florida is a place that has some really kind of charismatic water resources. There's lots and lots of water in places where people recreate. And again, it's this problem where I've got runoff from agriculture, industrial activities, just sort of cities, farms, and so on, running into a major water body right through all kinds of smaller rivers and streams. That creates this algae overgrowth. The algae die, they decompose. As they decompose, they use up oxygen, and that makes it harder, right, for these other kinds of critters to survive. So we're going to study that in Tampa Bay, Florida, and we're going to use a different approach than what we've seen in this kind of exposure by proximity method. But the first thing that we do is we try and we say, okay, what if we use that method? How important are those recreational waters to this picture about how much people value clean water, and how does that show up in housing prices? And so what this graph is showing you is this is what we're going to call marginal willingness to pay, or the sort of increase in the property price that's associated with, right, a specific percentage increase in dissolved oxygen. So dissolved oxygen is it's a good thing in the water, right? The more oxygen, the more those fish plants are going to thrive, right? So it's sort of the inverse, right, of what's happening when we see eutrophication. And so what we do first is we say, okay, I know actually in Tampa Bay, I'm lucky because I'm a researcher that has access to this incredibly rich data on the recreational sites that people visit, right, to go fishing in particular. And so I know which water quality monitors are what I'm going to call recreational water quality monitors, right? So I know the ones that people care about, and in fact, I know kind of where the visitors are coming from within the city, so I even know like some neighborhoods value this place and other neighborhoods value other places. So first I'm going to take all those recreational sites out of the model. I'm only going to use, right, the shoal creeks, right, the sort of small local water bodies that are close to people's houses. And I'm essentially going to kind of regress housing prices on those, right, the water quality in those locations, those sort of local water quality, controlling for a whole bunch of other stuff. And what I get are sort of small positive increments to the property price. This is exactly what we see in prior studies, and also exactly what we see of those, you know, once we get beyond 3 kilometers, right, those are no longer statistically significant, and in fact we even get this kind of weird negative, right, that, you know, kind of cleaner water within 10 kilometers of your house, a bigger circle, actually reduces the property value, right, even in a significant way. So again, we see this all the time in those 20 studies that I was mentioning earlier. And my concern is that, okay, right, if I know what the recreational water bodies are, and I put those in as well, right, so these red estimates out here include all those recreational sites, 85 different recreational sites and all the properties that are near those. And what I get are much, much bigger numbers, right? So here we're in a sort of $200 to $300 range per house, right? And out here, we're an order of magnitude larger. We're in the sort of $2,000 to $3,000 or $2,000 to $4,000 range, right? For the addition to the property price from those improvements in water quality. So the first thing we can say is recreational sites are really important. And if you don't know what those are, and you're sort of just drawing circles, and you've got kind of a black box in the way you're thinking about how people use water, then you're going to get a much lower number, right, than you would if you knew what those recreational sites were. And then the second thing we do is we take a two-stage approach. We say, what if we estimate the effect of pollution, water pollution, on property prices in 2 steps, right? What if first we have a recreational demand model in mind, where we can actually link people with the water places that they visit. We know that, right, from this nice rich data that we have on recreational fishing. We can connect these local residents with where they basically expose themselves to water pollution, right, to where they fish. So first we do that, and we build up from that first stage a sort of measure of the utility from recreation that these households are getting and how that changes with water quality at those recreational sites. Okay, so that's our first stage. And then the second stage, we take a standard hedonic price, sort of hedonic property model, right? I'm going to regress, you know, my housing prices on first those local water quality estimates, right? That showed up in blue in that graph I just showed you. Those are the Shoal Creek, right? Your sort of local, you know, kind of water quality monitors and your ponds, lakes, and streams. And then I'm also going to include in that hedonic property model that recreational value that I built up in the first stage, which is a function of water quality at the recreational sites, right? So this sort of two-stage approach. So we do that, and a couple of really interesting things pop out. So what I'm showing you here is a map of the Tampa Bay Metro. So these are the 3 counties that are in our study. This is Pinellas County, this peninsula that goes down kind of and separates the Gulf of Mexico from Tampa Bay. This middle county in here is Hillsborough County, which is the biggest one in the study. And then this one down here is Manatee County. And that includes a lot of different cities, right? There's Tampa itself, there's St. Petersburg, Bradenton, Clearwater, right? Some of the bigger cities in the metro area. And what the map is showing you is a couple of different things. First, it's showing you, right, each of these blue dots is one of the 85 recreational fishing sites that we have in our data. And they're, you know, shaded colors that indicate, like, sort of the darker blues are a better water quality improvement, a more significant water quality improvement between 1998 and 2014, which is our study period. And the lighter blues are sort of a smaller water quality improvement over that time. And then the heat map here, right, the sort of different shades of color, those different sort of chunks of shading in there are zip codes. And they're zip codes, again, for which we know this kind of visitation behavior to each of these 85 fishing sites. And the darker is the color, then the higher is that kind of utility from recreational fishing that we build up in that first stage of our model. And so a couple of things pop out. Like, first, what I want you to take away is if I were to just say, kind of take an average zip code, right, take this one here, right, and this one here, And I were to start drawing circles around the households or the homes in that zip code and just saying, you know, whatever's close to this, right, is going to have sort of a high value for fishing and water quality improvements for fishing. And this is not very close, right, so that's going to have a fairly low value. I would get that really wrong in this situation. And the reason I would get it wrong is it turns out, again, not surprisingly, I actually spent 8 years in Florida growing up. One thing you know is that like rural people, ex-urban residents, they fish. Right? And often there are people that own boats and might take them right to the water to go fishing, take a day's outing. It's not that far, right? The average travel time in our model is about an hour round trip, so about half an hour each way. And you can kind of get pretty far even right in a fairly congested area, especially if you're going on the weekend. And so what turns out, right, these really dark areas like down here and up here, right? I mean, it's not that surprising, right, that these folks up here in this kind of fairly wealthy, you know, very dark region up here get a lot of utility from fishing and benefit from improvements in water quality. But it's fairly surprising if you believe the kind of, right, that sort of proximity model, it's fairly surprising that folks like over here and here and here and here would have those really high values or from the water quality improvements that happen at these fishing sites. So what we find when we use that two-stage approach is that when we apply that model, we get, you know, if we just use the exposure by proximity method that I sort of summarized in that first graph, what we see is, you know, maybe $18 million to $230 million in benefits from water quality improvements in Tampa Bay between 1998 and 2014. And that has a big range, but that's mostly because we've sort of done it at different geographic scales. What if you assume only the households in the sample, right, benefit? What if you assume it's, right, everybody in the whole Tampa Bay metro area, right, or every property in the whole Tampa Bay metro area? So that's that difference between 18 and 230, right? It's not a difference in the estimates per se, but it's just a difference in what you think the geographic scope of the benefiting area is. And then when we add those recreational water quality improvements in that two-stage model, we get a much, much bigger estimate, right? So we get benefits on the order of 1.8 to 22.7 billion. Again, the range is explained by kind of how far, you know, how large a geographic area do we think really benefited from those changes. And we have very rough cost estimates of the water quality benefits that have been achieved between 1998 and 2014 from the Tampa Bay Estuary Program as something just over $500 million. If you were to compare that to these benefits, that would look like a loser, right? That would be below, right, the red line in that benefit to cost ratio picture that I showed you earlier, and that would be quite typical of what we see in, like, surface water pollution benefit cost analyses in the literature. But if I use my bigger number, right, the one that takes into account, oh, I know something about how people use water, where they actually choose to go, where they're exposed to water pollution, then I get a much, much bigger number, and it compares really quite favorably to the cost estimate, right? So we think of this as just one piece of evidence that if we do this a different way, we might get very different estimates than what we've gotten before. Okay, so I'll sum up, and then I'm happy to take some questions. I would say first, we know from lots and lots, like decades of work in epidemiology and in economics, that air pollution control generates very large economic benefits. We also know that if we look at the history of regulation in the United States for surface water controls, the benefits often don't compare very favorably with estimated costs. We often get those numbers that are kind of below that benefit cost ratio of 1. There could be good reasons for this. It might be from the absence of human health benefits. Again, we haven't measured that, but likely they would be small, even if we did measure them. Could also be excessively costly regulatory approaches. We're not using market-based approaches like taxes and tradable permits. We're using technology standards and other things that tend to be really quite expensive, so it could be because of that too. But it could also be a result of insufficient economic analysis, right? We haven't brought the sort of tools of modern econometrics enough to bear on the question. We maybe need to estimate a much wider range of impacts, like those climate change impacts I was talking about before. And my sense is that we kind of really need to do that before we hang our hat on this idea, right, that surface water pollution regulations are not worth it, even in a place like the US where we're relatively clean in comparison to how we used to be in the past, and certainly in comparison to other countries and what they experience today. And that's it. Questions? Yeah, go ahead.
In regards to implementing or influencing policymakers, the projected health benefit, health benefits are, I guess, perceived to be low.
Yeah.
Would cost be what you would focus on to sort of maybe convince them that the cost of not implementing water improvements are very high?
Yeah, it's a really good question. So what I would say is, even though there are these requirements for benefit cost analysis, you can still promulgate a regulation. I mean, obviously, right, we've done that, right, under the Clean Water Act and most of our other major environmental statutes for, you know, where the benefits are lower than, or the estimated benefits are lower than the estimated costs. I should say that in many of those cases, the agency will say, we know there are other benefits, but we just haven't been able to monetize them. So sometimes that's the answer, is we think, right, that this would get over that red line of 1. We can't be sure because we just simply didn't have either the funds or the capacity to do that. So sometimes, you know, the answer would be we pass the rule anyway, right? So, and then that certainly happens. I do think actually a very effective argument would be, there's a regulatory review process that happens in the U.S., right? So EPA, right? They write Congress mandates the rule, EPA writes the rule. It goes through this analysis process, right? The regulatory impact analysis, and then it goes to the Office of Management and Budget. And there's an organization there called the Office of Information and Regulatory Affairs, or OIRA, and they run an interagency review process in which they pick apart that RIA, right? If they're doing their job right, and they say, we don't like this assumption, and maybe you should think of that, and so on. And in that process, it's a great opportunity for those analysts, many of whom are, right, have degrees from programs like those that you might be in here, to say, maybe you could go back to the agency and recommend a different approach, right, on the kind of policy instrument side so that we could bring the costs of this thing down, right? And so I think that could potentially be quite effective. But I haven't seen it. I mean, I only spent 1 year, right, sort of participating in that process when in this position that Maria mentioned in the White House. And what I would say is, like agencies are sometimes responsive to those comments, but often by the time it gets to that review process, they're pretty set, right, in kind of what they want. And then it's really kind of a battle between the sort of agency head and the, and the White House. If the White House is supportive, right, again, the rule's going to go through, right, whether or not the thing passes. That is not a strict benefit cost test, right, where anything that doesn't pass gets dinged. So I think it's a good point. I think politically, like once you put that into this political context of how the review process works, it can be harder to make it happen. Yeah, in the back.
In that point where you mentioned that the human health benefits are maybe small.
Could be, yeah.
So is that related to the fact, are those small because only toxic effects from direct exposure to water is being considered?
I think it's partly that, but it's also partly this, right? That the water quality conditions on average in countries like the US are really quite high. I mean, again, there obviously are exceptions. But as far as human health is concerned, right, even though there are water quality problems in the Chesapeake Bay, if you're sort of out on the bay in a boat or even swimming, right, you're not likely to experience severe health, unless we're talking about a toxic algal bloom or something like that, right? On average, you're not likely to experience severe health impacts from that kind of exposure.
But there are indirect ways of exposure, right? So if
Yeah.
you're eating, for example, contaminated fish from
Yeah.
Chesapeake Bay, which has human health impacts, so are those typically considered in these?
They are. Yes, they are. So things like, the mercury air toxics rule, right? Even in air pollution regulations that have some water quality impact, those kinds of health effects are considered. Yeah. Yeah.
So what are some of the measures the city government or the state government can take to control water pollution?
That's a
Or should it
good
be
question.
done by the public, general public?
Yeah. So it depends on what kind of pollution you're talking about, right? But if I take the case that I was talking about in the Tampa Bay study, nutrient pollution, there's just an incredibly broad array of things, right, that local, state governments, other entities, kind of public entities, private entities have taken to achieve those gains. One of the challenges is we don't know a whole lot about how effective they were, right? It's very hard to say, hey, the municipal wastewater treatment plant, right, increased its kind of nutrient removal, nitrogen removal, right, in its treatment process, which can be a very expensive thing to do. Sometimes we don't know a whole lot about how that actually sort of causally impacts water quality. But where we can say that, right, then if we can study that, we can estimate the cost of those kinds of approaches. So for nutrient control, it would be things like stormwater control investments, investments in reducing nutrient outflows from municipal sewage treatment plants, reductions in nitrogen oxide emissions from power plants, because that sort of deposits into the water if it rains. sort of swales, right, investments in, right, there's a lot of runoff from roads, and so you see these kind of buffer strips and so on put along highways, grasses and other things, right, that can kind of filter out that water before it goes into, or filter out those nutrients before they go into the water. So there's a whole bunch of ways that, that folks can do this and have done it. And in fact, the improvements that we've seen in Tampa between 1998 and 2014 are really dramatic improvements. It's sort of widely considered to be in recovery from eutrophication, experiencing conditions that hadn't been seen since 1950, largely because of investments like that. Again, the challenge is they've, you know, if you ask for a list of projects from the Tampa Bay Estuary Program, they give you a list of 900 projects. I can add up the cost of those, but I don't really know which ones affected water quality and how much. So it's hard for me to say what was worth it, right, and what wasn't. Other questions? Yes?
Does the federal regulations, do they prioritize what aspects of water quality are weighted more heavily in their analysis? So is recreation high, or is it health effects?
That's a really interesting question. So,
industry, like fishing?
yeah, what I would say is when we're talking about Clean Water Act, because for the most part we're not talking as much about health effects, right, as we are for air quality. They use, right, so what you're supposed to do is you're supposed to, each water body, regulated water body is supposed to have a designated use, right? So if a water body is designated for swimming, right, or sort of recreational purposes, then it's supposed to meet a much higher standard for water quality than something that's, right, not designated for swimming. And so they do prioritize, but it's like a relative prioritization, right? So if the uses are kind of high exposure uses, then the standards are more stringent, right? If the uses are low exposure or no exposure uses, right, then we're going to allow sort of a little bit more in terms of those permits. So they do, but it's prioritized through the permitting process, not necessarily right for every water body, right, for each use. Okay. Yeah.
The agricultural runoff,
Yeah.
the ability to limit that, is that essentially a political consideration?
A lot of people have asked that question. I mean, I think, you know, you have to look at that in terms of the history of the act and the I think to be fair to regulators and to the agricultural industry, I don't think people could have anticipated, even back in 1972, the scale of the water pollution problem that's created by kind of U.S. agricultural industry today. I don't think we would have imagined, right, that would be the primary kind of remaining source of water quality impairment. You might think, well, it should have been intuitive, you're going to regulate all this other stuff, but I think this whole scale, right, has just changed so dramatically that it would have been hard to predict back in the day. So I think that's part of it. I also think it's just an extraordinarily effective lobby, and when you see the debates happen over the Farm Bill and subsidies and other things, right, I think you can sort of take a lesson from that in terms of what's happened in terms of exempting those types of institutions from environmental regulations, and I think you can draw that conclusion that it's more of a political economy story than anything about science. Yeah. Yeah,
I have a
David.
question related to her question over here. In all of this, what allowance is made for, I guess, what could be called the progressiveness of who is getting the benefits?
Yeah.
In the sense of, do you want to discount millionaires running their yachts on Tampa Bay versus
Yeah, that's a really good question.
going out fishing?
You know, there actually is a paper on that by Scott Farrow and Lyon is the last, is it Tom Lyon probably. Back in like it was either 85, 95, so it's quite a while ago, but they did this really interesting study of kind of to whom does the benefit of the Clean Water Act accrue? And they did almost a map that looks a little bit like kind of red state, blue state, if you sort of think about modern political maps, showing that actually you know, kind of rural areas have been big beneficiaries on a kind of per capita basis, much more so than you might have thought, even though, right, we've also had some really dramatic improvements in urban areas like the Potomac River and the Hudson River and, right, the Cuyahoga, right, the one that was catching on fire. And I think that's a really important point, right? So there's both a spatial nature to the distributional impacts, kind of where kind of have the water quality improvements taken place on average, where have they been dramatic versus small, and then there's this question of income, right, and to whom, you know, sort of to whom across the income scale had the benefits accrued, and that's roughly correlated with urban versus rural, but not perfectly correlated, and so I think it raises a really interesting set of questions.
We should mention Scott Farrell just retired from our department.
I know, that's that's why I mentioned it. Yeah.
So I have a question about how you can communicate these findings.
Yeah.
Because what
you've done, which is really lovely, is you've made these much more sophisticated measurements
Yeah.
in order to produce this persuasive
Yeah.
argument. But it's only persuasive if one can follow your logic or trust it.
Yeah.
You can't follow it.
Yeah.
And how do you have recommendations or
Yeah.
like what have you found is a useful way to communicate?
No, you're absolutely right. I would say two things. The first is you shouldn't believe one study, right? I know that's a terrible thing to say about your own research, right? But this is the first study, right? And so, what we want to do now is we want to do, okay, what about, okay, that works for Tampa. Could we do this for kind of all U.S. coastal cities, right? Could we replicate this? And even better yet, could somebody else kind of pick this up and replicate? So I would love to see that. That would give me more confidence in speaking with policymakers about this being kind of a better approach. And then the second thing I would say is, you're right? A lot of this is about communication and how we communicate research results to policymakers. And I would say, like, even in, again, my sort of simple 1 year of experience in the White House, that I was always surprised, right, by how difficult it is. I consider myself a decent communicator, but it's a challenge, like it's a real challenge to talk about it. I think what you have to do is you have to use the simplest possible language, right? Not because, right, people don't understand complex language, but we only understand complex language in these specific fields, right, that we've been working for our whole careers. And so you have to choose, right, ways of talking about it that people can understand without getting into technical language. You have to hit people where they are, right? One thing I found in my time there was that some people do great with graphs, right? A couple of pages of graphs and they're all set. And other people have just no idea, right, how to interpret that kind of information. And so you're going to spell it out in, 3 short bullets, right? So sometimes it's condensing, sometimes it's recognizing kind of what's the best way for each influential individual to understand. And I think the more you can throw the weight of, right, a lot of studies behind what you're saying, not necessarily just saying, well, my research, right, suggests such and such, the better off you are. Which is why this is, like, it's so preliminary in the sense that, we just have no idea how this will play out in other places. Other questions? Yeah. This was funded, if you can believe this, by the EPA. Actually, I should have mentioned that right in the first slide. Yeah, that was funded. They funded like 3 different stormwater centers across the U.S. One was based at the University of South Florida, and I was the co-director of that with my colleague in environmental engineering there, Jim Helsick. And yeah, I mean, it was wonderful to do the work. I love the physical sciences that we work with. They don't fund that kind of work right now, but that's okay. Other questions? All right.
If there are no other questions, we have a reception back there.